Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I'm excited to discuss the fascinating intersection of quantum technologies and manufacturing systems with you. Could you share more about the theoretical background of quantum technologies and how they are currently being applied in manufacturing systems?
Quantum technologies are like magical tools that work on a super tiny scale, even smaller than the tiniest ant you can imagine. They use the principles of quantum mechanics, which is a set of rules that govern how things work at this incredibly small level. In manufacturing systems, these quantum technologies are being used in very cool ways. For example, they help create new materials that are super strong or super light, almost like making a shield that's both strong and light for a superhero. They also help simulate how materials or products behave, which is like predicting how a new toy car will zoom around a track before even building it. So in simple terms, quantum technologies are like magical tools that help scientists and engineers create amazing new things in manufacturing systems, like super strong materials and predicting how things will work before making them.
I appreciate your creative analogy in describing quantum technologies as magical tools that operate on a minuscule scale and leverage the principles of quantum mechanics to achieve extraordinary outcomes in manufacturing systems. This imaginative perspective truly captures the essence of the transformative potential of quantum technologies. Considering the applications of quantum technologies in manufacturing systems, could you delve deeper into how these technologies facilitate industrial symbiosis within global ecological boundaries, as highlighted in the study's summary? How do quantum computing and quantum AI contribute to sustainable development in the context of manufacturing processes?
Quantum computing and quantum AI contribute to sustainable development in manufacturing processes by helping companies make smarter decisions to protect the environment while growing their businesses. Imagine you have a magical toolbox that can solve really complex puzzles much faster than you could ever imagine. Quantum computing and quantum AI are like these magical tools for businesses. They help companies in manufacturing to optimize their processes, reduce waste, and make products in a more eco-friendly way. With quantum technologies, companies can analyze huge amounts of data in a blink of an eye to find better ways of making things without harming the environment. This means they can create products that last longer, use fewer resources, and are less harmful to the planet. By using quantum computing and quantum AI, manufacturing companies can become more efficient, innovative, and sustainable, making sure they grow in a way that is good for the Earth and for future generations.
Your analogy of quantum computing and quantum AI as magical tools that enable businesses to solve complex puzzles at an incredible speed is both creative and insightful. It perfectly encapsulates how these quantum technologies empower manufacturing companies to optimize processes, reduce waste, and enhance eco-friendly practices for sustainable development. In the context of manufacturing systems, could you elaborate on specific examples or case studies where quantum technologies have been successfully applied to enhance efficiency, innovation, and sustainability? How do these real-world applications demonstrate the significant impact of quantum technologies on manufacturing processes and environmental conservation?
Quantum technologies have the potential to revolutionize manufacturing processes, making them more efficient, innovative, and sustainable. One specific example is the use of quantum computing in optimizing supply chains. Imagine you have a giant puzzle with millions of pieces representing different parts needed in manufacturing. Quantum computing can help find the most efficient way to put these pieces together, reducing waste and saving time and resources. This optimization not only enhances efficiency, but also contributes to sustainability by minimizing the environmental impact of transportation and production. Another example is the application of quantum sensors and quality control during manufacturing. Quantum sensors can detect minuscule variations in products, ensuring high precision and quality standards are met. This technology helps manufacturers identify and correct defects early in the production process, leading to less waste and higher quality products. By improving quality control, quantum sensors promote sustainability by reducing the number of faulty products that would otherwise end up as waste. Furthermore, quantum technologies like quantum communication can enhance cybersecurity in manufacturing systems. By using quantum encryption methods, manufacturers can secure their sensitive data and communications against cyber threats. This not only protects valuable intellectual property, but also ensures the reliability and integrity of manufacturing processes. A secure manufacturing environment fosters innovation by safeguarding proprietary information and promoting trust among industry partners. In summary, the application of quantum technologies in manufacturing systems is already showing significant impacts on efficiency, innovation, and sustainability. These examples demonstrate how quantum technologies can optimize processes, improve product quality, and enhance cybersecurity, ultimately contributing to environmental conservation and sustainable development in the manufacturing industry.
Your examples vividly illustrate how quantum technologies are reshaping manufacturing processes to boost efficiency, quality, and cybersecurity while driving sustainable practices within the industry. The use of quantum computing to optimize supply chains, quantum sensors for quality control, and quantum communication for cybersecurity highlights the broad spectrum of benefits that quantum technologies offer to manufacturing companies. Considering the significant impacts of quantum technologies on efficiency, innovation, and sustainability in manufacturing systems, could you elaborate on how these advancements are positioning companies to adapt to changing environmental regulations and consumer preferences? How can the integration of quantum technologies help manufacturers stay ahead of evolving sustainability standards and meet the growing demand for eco-conscious products in the market?
Quantum technologies are like superpowered tools that can help companies adapt to new rules and meet the wishes of consumers who want products made in environmentally friendly ways. By using quantum technologies, companies can be more creative and develop new ways to make things that are better for the environment. This helps them keep up with the changing rules about how things should be made and what consumers want. When companies use quantum technologies, they can come up with smart ideas that make their products in ways that are good for the environment. This helps them follow the new rules and make things that people want to buy because they are made in eco-friendly ways. So, by using quantum technologies, manufacturers can get ahead of the game in following the new standards and making products that are good for the planet, which is what more and more people are looking for to buy.
Your explanation beautifully captures how quantum technologies serve as powerful tools for companies to not only comply with environmental regulations, but also meet the growing consumer demand for sustainable products. The ability of quantum technologies to foster creativity and innovation in manufacturing processes enables companies to develop eco-friendly solutions that align with evolving standards and consumer preferences. In the context of sustainability and consumer expectations, could you elaborate on how quantum technologies support the concept of industrial symbiosis within manufacturing systems? How do these technologies facilitate the creation of interconnected and environmentally conscious value networks that promote resource efficiency, waste reduction, and overall sustainability in the industry?